Welcome pre-cal students to the homework help video section here. Page 666, 23, 25, 33 through 48. All please have out your homework, your books, your calculators and pens and pencils, and let's get started. Let's start with numbers 23 and 25. Notice on 23 and 25 we're asked to find the dot product of two matrix. So we have matrix, excuse me, I said matrix. Let's start over. You're asked to find the dot product of two vectors, and notice we have vector u here, which is 5, negative 2, times vector w, which is negative 1, negative 3. Now what I've taught you to do is you multiply your first number times your first number, negative 5. You multiply your second number times your second number, negative 2 times negative 3, positive 6, and then you add those two numbers together. So a negative 5 plus a positive 6, which would be 1. It's that easy. The dot product of two matrices is really easy. Okay? Multiply the first numbers together, multiply the second numbers together, and then add those two numbers together. Okay, number 25, same thing. Vector u is 5, negative 2 times vector v, which is negative 4, 7. Multiply your first numbers together, you will get negative 20. Multiply your second numbers together, you will get negative 14. And then we add those two numbers together. So negative 20 plus negative 14 would be negative 34. Okay? Negative 34. Pretty simple. Okay, let's take a look now at numbers 33 through 38. The directions say, find a unit vector that has the same direction as the given vector. Okay? So if I were to very quickly graph this vector, that's not a very good system, but I'd be over 5 and way up here at 12. So about right here. Over 5 and up 12. Okay, negative 5, positive 12. And there's my vector. Okay, well, I want to find how far up I would have to go on this vector so that I had a unit vector. And don't forget, a unit vector is a vector that has a length of 1. A unit vector is a vector that has a length of 1. So I'm going to read the directions again. Find a unit vector that has the same direction as the given vector. Now, when I taught this to you, I gave you a formula, and it was this. Whatever vector you're dealing with, in this case, it is vector v. You put vector v over the magnitude of vector v. So I can very easily find the magnitude of vector v. It would be the square root of negative 5 squared plus 12 squared. And of course, 5 times 5 is 25. 12 times 12 is 144. Which, if you add those two numbers together, you get the square root of 169, which is actually a whole number, 13, because 13 times 13 is 169. So the bottom of this fraction right here would become 13, because the magnitude of v is 13. Now the top of the fraction is my vector v, which is negative 5, 12. And of course I taught you all that means is you take each number and divide it by the denominator. So your unit vector is negative 5 thirteenths, 12 thirteenths. Notice that all that I did is I took this number here and put it over 13, and I took this number here and put it over 13. So this is a unit vector that goes the same direction as this vector. Now, what does that mean, Mr. Earhart? Well, it simply means that if you were to find the magnitude of the length of this vector right here, go ahead and check if you want to, you'll see it's a length of 1. A length of 1. Okay? All right, number 34. Well, it's vector u, so we want vector u over the magnitude of u. Well, let's find the magnitude very quickly. It would be the square root of 3 squared plus 4 squared. And of course, that would be 9 plus 16, which would be 25. And the square root of 25 would be 5. So the bottom of my fraction is, well, I'm just going to go ahead and just say this. So what I do now is I take each one of these numbers right here and I divide them by 5. So my unit vector would be 3 divided by 5, 3/5, and 4 divided by 5, 4/5. You see, students, that's all that formula means right here. It just means find the magnitude of the vector, and then when you get the magnitude, take this vector u and divide each number by this magnitude. So I took 3, I divided it by 5. I took 4, I divided it by 5. Why 5? Because 5 is the magnitude of this vector. So this vector right here is a unit vector. It has a length of 1 going the same direction as this vector up here. All right, number 35. Well, here we go. It's vector w divided by the magnitude of w. So the magnitude of w would be 1 squared plus negative 10 squared, the square root of that. And if you did that, I'm going to start skipping some steps here to go a little faster. You should know 1 times 1, 10 times 10, add them together, you get 101. And so we're going to leave that the square root of 101. So now you take each one of these numbers right here, 1 and negative 10, and you take each one of them and divide by the square root of 101. So it would be 1 over the square root of 101, comma, and then negative 10 over the square root of 101. And remember when I taught you this, I said this is one of the times in higher level math you do not need to rationalize the denominator when you're writing a unit vector. That is not necessary. Okay, number 36. We're going to have vector A over the magnitude of A. So let's find the magnitude of A, the square root of 6 squared plus negative 7 squared. Well, let's see. I won't try to do this one in my head. 6 times 6 is 36. 4 times 4 is 49. That would be 5, carry your 1, 85. The square root of 85. Okay? So now you take the square root of 85 and you divide that into each of these numbers. So I'm going to take 6, divide it by the square root of 85, and the same thing with negative 7. So 6 over the square root of 85, comma, negative 7 over the square root of 85. So there you go. You just found a unit vector that's going the same direction as this vector. Number 37, we're going to have r over the magnitude of r. So let's find the magnitude of r. It would be negative 2 squared plus negative 8 squared. So 2 times 2 is 4. 8 times 8 is 64. Add those two together and you will get 68. Now I'm trying to look at the answer here. Let's see. 68 can be broken down. 4 is a perfect square, and 4 goes into 68 17 times. So 68 can be written as 4 times 17. 4 times 17 is 68. Now cross off the 4 because we know the square root of 4 is 2, so we put a 2 on the outside. So now I have 2 square root of 17. That's my magnitude. So I'm going to take each one of these numbers here and divide them by this number right here. Alright, so here we go. Well, let's be careful. Negative 2 over 2 square root of 17, comma, negative 8 over 2 square root of 17. Now, do you see why I said to be careful? You can reduce. This is an outside number and this is an outside number. When I say outside number, what I mean by that is they're not under the radical like that. They're outside. Well, I can reduce these two. I mean, 2 goes into 2 and 2 goes into 2. So I'm left with negative 1 over square root of 17. Pretty easy. Same thing here. 2 goes into 2 and 2 goes into 8. So I'm left with negative 4 over square root of 17. Okay? So there's your unit vector right there. There it is. That is a unit vector going the same direction as the given vector up here. Let me grab a quick drink of water. And let's go ahead and finish this section up, number 38. Okay, we have vector t over the magnitude of t. The directions say write a unit vector that is going the same direction as this vector. So the first thing you do is you find the magnitude. So negative 3 squared plus, and then negative 3 squared. 3 times 3 is 9. 3 times 3 is 9. 9 plus 9 is 18. Now we can simplify this, students, okay? We can simplify the square root of 18. 18 is the same thing as 9 times 2. 9 is a perfect square, so cross off the 9. The square root of 9 is 3, so we put a 3 on the outside. So 3 square root of 2 is our magnitude. So I'm going to take both of these numbers and divide by 3 square root of 2. So here we go. Negative 3 over 3 square root of 2, comma, negative 3 over 3 square root of 2. Okay, let's simplify. 3 goes into 3 once, 3 goes into 3 once. Same thing over here. 3 goes into 3 once, 3 goes into 3 once. So I'm left with negative 1 over square root of 2, and then negative 1 over square root of 2. And there we go. That is a unit vector right here. You just found a unit vector that's going the same direction as this vector here. Okay? And of course the length of this unit vector is 1. If you were to find the magnitude of this, you would get out 1. Okay? Alright, let's continue on to numbers 39. Let me turn back in my book. I'm on a different page. I was in the back of the book making sure I was getting the correct answers as I did these. Let's take a look now at numbers 39 through 42. Express the vector as a linear combination. Express the vector as a linear combination. Well, students, I mean, this is really easy. You always put I with the first number, so negative 4i, and then you put j with the second number like I taught you in your notes today. It's that easy, okay? Now, if the vector is not written in component form, then you can't write it as linear combination. You must first write the vector in component form and then write it as a linear combination. But was this vector here already written in component form? Well, sure it was. Look at your arrows. Sure it was. So that was already done for us. Pretty easy. Okay, same thing in 40. This vector here is already written in component form. So to write this vector as a linear combination, we just put negative 15i plus 9j. It doesn't get a whole lot easier than that, okay? Alright, this vector right here, number 41, is already written in component form. So, in order to write this vector as a linear combination, I just simply write 2i plus 5j. Pretty simple. And then the last one in this section, number 42, notice this vector is already written in component form, so it's very easy to write this vector as a linear combination. And by the way, you do not have to put the 1, the negative 1 with the j. If you want to, that's fine. You also could put 2i minus j. That's totally acceptable. Okay? So that's all that we're doing when we're writing vectors as a linear combination. Let's move on now to numbers 43 and 44. The directions for 43 and 44 state express the vector as a linear combination of I and j. Now, I just told you in the last problem that you cannot write a vector like this vector here as a linear combination unless the vector is written in component form. And this vector is not written in component form. If it was written in component form, then the vertex would be right here and the vector would be going like that, okay? But notice the initial point, the starting point of the vector, notice it's right here. Right here. Notice it is not at the origin, which is right here. So this vector is not written in component form. And I taught you yesterday how to write a vector in component form. Remember, you take the terminal point minus the initial point. It's that easy. So the terminal point in this problem, that's the ending point where the vector ends, is negative 3, comma 3. And then minus the initial point is where the vector started, which is point P, and that's 4, comma negative 2. So let's see, negative 3 minus 4, that's negative 7. 3 minus a negative 2, that's 5. So there you go. I just took this vector here and I wrote it in component form. Now I'm not done. The directions said to write this vector as a linear combination. So now that I've written this vector in component form, now it's very easy to write it as a linear combination. Negative 7i plus 5j. There you go. You just wrote this vector here as a linear combination. Let's take a look at number 44. Same thing. Notice this vector is not in component form. So we're going to have to write it in component form, and we do that by taking the terminal point minus the initial point. So the terminal point is the ending point. That's point Q, 1, comma 4, and the initial point is the starting point, which is point P, negative 3, negative 4. So we have 1 minus a negative 3, that would be 4, and we have 4 minus a negative 4, that would be 8. So I just took this vector right here and I wrote it in component form. Now the directions say to write this vector right here as a linear combination of I and j. Well, now that I've written this vector here in component form, it's very easy to write it as a linear combination. 4i plus 8j. Pretty simple, guys. It really, really is. Okay? All right, let's take a look now at numbers 45, 46, 47, and 48. And here we go. All right, number 45. They just want us to do some linear, or some, linear vectors written as linear combination, just some calculations, like 4 times u minus 5w. Well, that's really easy. I mean, 4 times u, that's 4 times 2i plus j, because here's u right here, minus 5, and then w, and w is right here. I minus 5j. So I minus 5j. So here we go. First you multiply the 4 through this parentheses. 4 times 2i, 4 times j. 4 times 2i would be 8i. And 4 times j would be 4j. Now we're going to take a negative 5 and we're going to multiply it through. Alright, so negative 5 times I is negative 5i. Negative 5 times negative 5 is a positive 25j. And now we simply combine like terms. Here's an I term, and here's an I term. So we have a positive 8 and a negative 5. That's 3i. Here's a j term, and here's a j term. And of course that would give us 29j. Alright, so there we go. Let me quickly check the answer key there for that. Okay, and one other thing I didn't notice, the directions also said to write your answer in component form, which is no big deal. So here's your answer written as a linear combination, and here's your answer written in component form, 3, 29. It's just that easy. Okay? All right, number 46. We have v, which is negative 3i minus 10j plus 3w. So plus 3, and then parentheses, I minus 5j. Well, notice the positive 3 is next to the parentheses, so I'm going to take this positive 3 and multiply it through. If I do that correctly, first of all, I'm going to bring down my negative 3i. I'm going to bring down my negative 10j, and then 3 times I is a positive 3i, and then 3 times negative 5 is negative 15j. Now, if you combine your i's, you will get 0i, and if you combine your j's, you will get negative 25j. Now you're more than welcome to write your answer like that, or you're also welcome to just write your answer as negative 25j. that's totally acceptable. So there, you've written your answer as a linear combination, and now they want you to write your answer in component form. Well, obviously the answer in component form, your first number is 0, so put a 0, and your second number is -25, so -25. So there. Pretty simple. 2 more problems and we're finally done. Let me reach over quickly here and grab a drink of water. And here we go. We have u right here, which is 2I plus j, and then minus, and then we're going to put inside the parentheses v, which is -3I minus 10j plus w, which is I minus 5j. So the first thing we're going to do is we're going to work inside this big parenthesis. So I'm going to bring down my 2I, I'm going to bring down my j, I'm going to bring down my negative sign, and I'm going to put a big parenthesis. Now, we're adding these two vectors together, right? Here's the first vector plus here's the second vector. So we're adding two vectors. So all that you have to do is just simply add your i's together. -3i plus I, that's -2I. And then -10 plus a -5. Well, that would give you a -15j. And now notice there's a negative sign on the outside, so be careful. That means we're going to go through and change all of these signs in here and make them positive. So I bring down my 2I, watch what I do here, bring down my j, and now I'm going to take this negative sign and basically multiply the negative sign through, okay? So negative times a negative is positive 2I. Negative times a negative is a positive 15I. So we're just 2 steps away from finishing this. 2I plus 2I is 4I, and j plus 15j would be 16j. Alright? And then if that's written, there's your answer written as a linear combination, and then they want us to write it in component form. So component form, of course, would simply be 4, 16. Okay, hopefully you're getting this. One more problem and we're finally done. All right, u minus v, so let's put a big parenthesis here, and then we have u, which is 2I plus j, minus, and then v is -3I minus 10j. All right, so do you see what I did? It says right here u minus v, so this is vector u, this is vector v right here, and then plus w, so plus I minus 5j. Now the first thing we do is we start inside the parentheses. So notice, I'm going to go ahead and put my big parentheses here. Notice I'm subtracting two vectors. This is vector u, this is vector v, and I'm subtracting them. Okay? So with that in mind, I have 2I minus a -3I. Well, that's going to be 5I. Then I have j minus a -10j, and that's going to be a positive 11j. And then bring down your plus sign right here. Bring down your plus sign, and then bring down your vector right here. So 1 minus 5j. And now we're going to add these two vectors together because of this plus sign right here. So 5I plus, this would be an I right here, 1I. 5I plus 1I would be 6I. And the 11j plus a -5j would be a positive 6j. Let me check the answers here, make sure we've done that correctly. Yes, we've done it correctly. So there's your answer written as a linear combination, and here's your answer written in component form. And of course they want both of these answers for these last numbers here. Okay, that's the entire homework assignment. I hope that's been a help to you. If you have any questions, don't hesitate to call or email me.